Okay, let's be honest with each other. If your teacher assigns you this problem, they cannot be a nice person. Wow, look at this circuit. Oh goodness, it's split up all over the place. Well, I'm not going to worry too much about it. Matter of fact, what I wish I could like blow it up gigantic size. It's easier to work these on the whiteboard than anything else. But what I can do is this. Think about trying to make this circuit smaller and smaller. A 10 and a 10, look at these two. 10 plus 10, they're in a series. That means I could replace that 10 and 10 with what? A single 20 ohm resistor. I ain't going to write my units because it's going to get kind of messy. Wait a second. Here's a 10 and a 10 on the bottom of this. Oh my goodness. That means I could replace both of those with a single 20 ohm resistor. Hey, now look at something. 10 and 10, 10 and 10. Now you've got a 20 over a 20. Wait a second. I know how to reduce that. Those two are parallel to each other. How do you reduce resistors that are in parallel to each other? Wait a second. I can reduce this whole section. 1 over 20 plus 1 over 20 is 2 over 20. The reciprocal of that is 10. So I could replace the entire top part of this circuit with nothing but a single 10 ohm resistor. So check it out. I've now got rid of everything up there and replaced it with a 10. Wait a second. Look at the bottom. You've got a 10 and a 10 on bottom. Look at how these two are stuck on each other. 1 over 10 plus 1 over 10. What could we replace these two with? A single 5. Now I know this thing's still kind of ugly looking right now. But now look at this. Now you've got a 5 and a 10 that are in a series with each other. What do you do for a series? 5 plus 10. Now, if you've gotten lost, what I'm saying here is this. Go through, work it out. There's 4 resistors on the top part of the circuit. But the reality of it is, all 4 of these resistors, by the time you combine the series, combine the parallel, we could replace all 4 of those resistors with a single 10 ohm resistor. Now look at the bottom. 10 and 10 makes 5. 5 and 10, wait a second. I'm saying we can go back and replace everything on the bottom. 10 and 10 is 5. 5 plus 10. I'm saying we could replace everything with a 15 ohm resistor. And then we've got this 10 stuck out here. Oh goodness. This picture might have been hard, but look at that one. Hey, we've done this one a bunch of times. How can we reduce this? 1 over 10 plus 1 over 15. Let's do that in the calculator. We don't need to, but 1 over 10 plus 1 over 15 is 1/6. Oh, check out this, crazers. The reciprocal of 1 over 6 is 6. Ah, that's crazy. So we could replace this 10 and 15 with a single 6, which means we could replace both of those with a 6 and a 10, which means my R total is nothing but 16 ohms. So we could take this entire picture, every single resistor combined, and make that 16 ohm R total. Hey, what were the first 3 things I said to find in my other videos? I said, if you're doing this, find for me V total, R total, and I total. Wait a second. Well, I'm doing pretty good. V total, where's my picture at? It's 20 volts. So there's my V total. My R total is 16. I just got that. Hold on a second. I'm on fire. Not literally. It's just a figure of speech. But look at I total. V equals IR. It's the only equation I'm going to use to answer every other question. This is all I need. Once you get R total, V equals IR. That's all I'm going to use. So this is 20 equals I times 16. Wait a second. 20 divided by 16, that's 1 1/4. 1.25 amps. Man, I found a lot of information here already. I want you to go back to something. That means leaving this battery. I'm going to go all the way back to this one. I'm going to draw my battery. Here's my battery. That means leaving my battery. Leaving the battery is 1.25 amps of electricity. So how many amps is flowing through here? Wait a second. 1.25 amps. How many amps is flowing through here? 1.25 amps. Hold on a second. I might have a hard time looking at that big old picture, but this picture I can get. I just said in my last video, if I get this, I want to find this V. What do you want to call it? V1? Sure, we'll call that V1. How do you find that V1 for this section? Wait a second, I got this. V1 is equal to C. V1 will be equal to, oh, come on, what's the only, wait a minute. IR. It's the only equation we're going to use. What is I? 1.25. What is R? Wait a second. It's 6. You get, shut the front door. 1.25 times 6, that's 7.5. So I've found a V, 7.5 volts. And you're probably saying, well, congratulations, you have a V now. I know, thank you. 7.5 volts. The reason why I needed that V was simple. One of the questions it asked is this. It called it I2, right here. It asked to find the amps through the bottom half. Where is it? I got resistors going everywhere. It asked for me to find how many amps are going through the bottom half of this big circuit. How many amps is... I don't want to look at this picture. It looks crazy. But I can see that amps is the bottom of this circuit. It's this picture. How many amps is this? Wait a second. What's the only equation I can use? V would be equal to I2R. Oh, snap. What's my V? Well, for this, it's 7.5. So 7.5 equals I2. And I2 is trying to go through a 15 ohm resistor. Oh my goodness. 7.5 divided by 15 is a half. I've got half an amp of electricity trying to flow through the bottom of this thing. Now, this is where most people would give up and quit. If they got to here, they'd quit. Well, I got to do something. I got to go back. And oh, by the way, let's do something. There's a half an amp here, and there's 1.25 amps total. How many amps are going through the top? 0.75 amps must be going through the top. It didn't ask for that, but good grief. It's pretty easy by the time we've gotten to here to figure out these amps. Now, let's do something. This is what I'm going to consider the hardest question on the whole thing. Most people can't do. I want to go back and I want to look at this. I want to look at this picture right here. We just found that there's a half of an amp coming into here. That means flowing through here is half an amp. And I hope the second I drew that line and wrote half an amp, that just told you exactly what's about to happen in this problem. There's a half of amp in this section. Let's draw that section up really big so that we can look at it. See what we got. It looks like this. Dun, 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 dun. Oh, we could use common sense even. Oh my goodness, we don't even need to do any math and we could figure this one out. 5, you have a 10 and a 10. You should already be answering this for me. And a half of an amp in here. There, somewhere underneath 30,000 pieces of paper. Look at what I've got. Here comes that half an amp. It's going to split. Part of it this way, part of it this way. This problem actually asked me, it called it I3. It wanted to know how many amps went through this top split. Well, look. These pipes are clogged the same. 10 and 10. Oh my goodness. That means there's going to be a quarter of an amp go this way and also a quarter of an amp going that way. Hold on. How could we prove it? If this problem wanted me to prove it, I do it the way I know to work them. Every time you see this, we can also go back here. We can call it V4. I don't care what we call it. But we can find the V. What would be the V for this section? V4 equals IR. A half of an amp times 5 ohms is 2.5 volts. That means there's 2.5 volts in this section. So if I want to know I3, V equals I3R. V is 2.5. I3 and R is 10, which makes I3 0.25 amps. Alright, I know what you're thinking. How'd you become such an awesome resistor person? It's just practice. It's just practice. Which is what you need to be doing right now. So good luck. Thank you for watching and have a blessed evening. Yeah, that's right. Anyway, love y'all. Be good out there. Bye.